So if you look at the GitHub statistics alone, maybe we chose the wrong programming language. I'm going to tell you why that's probably not the case. So what you came here to hear about tonight is this project called Quercus. You can find out more about it at Quarkus.io is the website. And we've kind of branded this as Supersonic, Subatomic Java. Now, if you're familiar at all with Java, you probably don't think of Java as being small and super fast, because back when Java first started, it took a while for the Java virtual machine to start up, and it wasn't exactly immediately fast. Unfortunately, that perception has dogged Java for a number of years, even though it's no longer true and hasn't been true for quite some time. But we're going to take existing Java skills, or if you want to develop new Java skills, and we're going to bring them to cloud native, where you're seeing a lot of people go serverless with JavaScript or Go, because Go has fast startup times and it's supposed to be highly performant. I'm going to show you why that's not necessarily true. What is Quercus? Well, Quercus is a faster, more convenient, cloud-native, container-friendly runtime on the Java virtual machine. So the Java language is okay. It's like any other programming language. It has its problems. It's not perfect. But what really makes Java shine is its runtime, the Java virtual machine that runs the bytecode that you create. And why is that? Because the Java virtual machine, over the last 20 plus years, has become super smart at optimizing your code for you. In general, you can write some pretty crappy, non-optimized, very easy to read code in Java, and the just-in-time compiler, hotspot, within the JVM, will make it fast for you without you really having to do much. And that is the gold that makes Java amazing. So, why should I care about Quercus? Well, Quercus takes that concept of Java being highly performant and makes my code run well regardless to the next level of cloud computing with faster startup times, lower memory footprints, comparable to native binaries written in Go or C. So I'm talking startup times in the sub-microsecond. If you've ever seen a JVM start up, sub-microsecond is not something you would imagine to be possible. It's not even possible with JavaScript. The V8 engine takes almost 800 milliseconds to start up and start executing code. So if I'm going to use Quercus, what do I need to learn? Well, the spoiler is not much. And how does it work? Well, it's not magic. And then we're going to do some live coding at the end. So why should I care? I already use Java or Java EE or Spring Boot or name your preferred framework. Why should I consider changing? Why would I want to rewrite any of my code and use Quercus? What it really comes down to is Quercus is designed to be cloud native, whereas the Java virtual machine has evolved over the last 20 plus years to run on big servers, not in cloud instances that run horizontally scales of thousands or hundreds of thousands of instances. So Quercus takes your existing Java knowledge and makes it possible for you to scale it at cloud scale. This is a really common sentiment. Nobody puts Java in a container. Well, up until recently, it was very common if you put Java into a container and tried to run it on Kubernetes or in Docker or whatever, it would get an out-of-memory killer and it would crash. And you would have no indication as to why. Linux would just say, yeah, your Java app tried to take too much memory. And put the hammer down. This is because up until some of the most recent releases of Java 8, Java didn't understand the concept of containers. It just said, oh, system, how much memory do you have? And the system would say, I have 14 gigabytes. But you're in a container and you're only allocated 4. And Java said, all right, I'm going to allocate 14 gigabytes. And the operating system said, whoa, 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 whoa. Die. So this has mostly been fixed in the latest updates of all the Java releases, 8, 9, 10, 11, and 12. but it's still not perfect. And this is what it looks like in your logs when you get an out-of-memory killer. Have anybody ever seen this before? I've seen this way too many times in containers. It's very, very frustrating because you don't know why it got killed or how it decided what gets killed. It's interesting. So just to give you an idea of what I'm talking about with these startup times, this is a Hello World Spring Boot app and starts up in 0.997. That's 997 milliseconds. All right? Quercus, running in dev mode, starts up in 755 milliseconds. Now, that's not an amazing improvement, but Quercus has a superpower. You can convert a Quarkus Java application to a native operating system binary and do away with the virtual machine for the most part, and we can achieve 5 microseconds as our startup time for a Java application. In addition to this, the memory footprint is significantly reduced. So what do you need to learn to be able to use Quarkus? You're going to love this. It's really complicated. So here's a typical Spring REST controller. I don't use Spring very often, so anybody here who knows Spring better than I do, if I show you something incorrect, please correct me. Don't feel bad about saying, hey, you're wrong. I do that all the time. I'm wrong at least 10 times a day. But this is a pretty typical REST controller in Spring. Would you agree, Austin?
Yeah.
All right. So we've got our mapping that says that, this is a hello endpoint, and it returns hello Spring Boot. And watch very carefully. There's going to be a lot of changes between this and the Quercus implementation. Did you see it? Oh, wait. Okay, the package name changed. That's just an arbitrary name. I decide what that name's going to be. And the string, the hello string, changed from Spring Boot to Quercus. None of the import statements changed. None of the code syntax changed. This is because Spring Boot is an open source project. We can implement their API. Everything that makes Quercus special really happens under the hood. It's done via the Quercus Maven plugin and via a tool we're going to talk about in detail, Growl. Has anybody here heard of Growl or Growl VM? Graal? All right, we'll get into that. So let's say you come from John's World where you work in Enterprise Edition. This probably looks more familiar to those people. This is JAX-RS for defining REST APIs. And we're going to convert this Java EE. This is straight out of the Java EE specification. We're going to convert this to Quercus, and this one's really tough. Ugh. What? Oh, I changed the package name and the string again, and that's it. So you're telling me I don't have to change any of my code? You don't have to change the majority of your code. The plain Jane simple stuff all just works in Quercus. What you're going to run into problems with is that in Quercus, since we don't have all of Spring Boot replaced, or we can't implement things like Spring Security. We do have a security solution in Quercus. It's just not the same as Spring Security. We don't have all of these same extensions for Spring Boot available in Quercus. We have Spring DI, we have Spring Web, and we have Spring Reactive available. But you can use almost any other library. All right, what about database access? I know a lot of developers love Spring Boot because of repositories. They're super easy to write database access in. What about doing data access in Quercus? Well, here is a very basic implementation using Spring Data JPA. So you have your data source, your application configuration bean for Spring. You have your entity. In this case, it's a to-do app. and you have your REST controller that implements and uses your repository. All right. In Quercus, we have this. We have an entity, and the big difference here is that the entity extends panache entity. Panache is like a really nice veneer on top of JPA, specifically Hibernate. And basically, it turns your entity object also into your repository object automatically. And then you just call your entity.listAll or find by ID or persist. Similar to the way you would do it with a Spring Data repository. And it does a little extra magic. And I actually made a mistake here. I just noticed I put an ID here in this entity. If you're extending Panache entity, Panache will automatically add a long ID field to your entities. You don't have to worry about that. It's automatic. If you want to set your own ID field and strategy, you can extend Panache entity base, and you get the same functionality. You're allowed to set your own ID field. So from this to this, that's a pretty big difference. So how does it work? Well, the short answer is GraalVM and a tool called Weld. So what is GraalVM? GraalVM is a universal virtual machine for running applications written in JavaScript, Python, Ruby, R, Java, Scala, Groovy, Kotlin, Clojure, C, C++, and the list keeps going on. Think of it, Graal is a new type of Java virtual machine in which the just-in-time compiler, the hotspot optimizer, itself can be extended and modified using Java code. That's the real magic of GraalVM. It's an optimizer that can be itself optimized. And you can tune how you want it to optimize your code in different ways because it's programmable. The other superpower of GraalVM is that it can take Java bytecode, like a jar file, and it can take out all the crap that you're not actually using, because 90% of the time when you include a library, you don't use all of that library. Or if you use a framework, you don't use all of that framework. GraalVM with the Quarkus Maven plugin will strip out all the stuff that you don't actually use, convert that bytecode to a native binary, and strap it onto something called Substrate VM. And Substrate VM is like a really, really stripped down, bare bones, basic Java virtual machine. And it compiles it together into a single executable file. So you still get garbage collection, you still get optimization, but it's now a native executable with a 5 microsecond startup time. The size of the binary is comparable to Go. The startup time is comparable to Go and C and C++. Memory utilization is comparable to Go and C and C++. And the big deal is that when you use Graal to compile a native image, this is where you have one restriction. Because everything is being stripped down to the bare minimum you need to run, there are two things within the Java world that many frameworks use that you cannot use in a native image. The first is reflection. Has anybody here heard of reflection? Okay, so some of the Java devs. Reflection is a way of introspecting your code from within your code. It's basically meta-programming. You're modifying your program at runtime. That's what reflection is all about. The second thing is dynamic class loading. So in Java, you load up all your classes, but sometimes at runtime, you'll reach out and you'll add additional functionality to your program, and that's called dynamic class loading. Because we're baking this into a single native binary executable, we cannot bring in dynamic classes using Graal. So Red Hat, in conjunction with the open source community, has updated their dependency injection tool, Weld. Weld has been around for a long time as part of Java EE spec, Java Enterprise Edition specification. It's the reference implementation for what's called contexts and dependency injection in Java Enterprise Edition. And what they did is they used Weld to introspect all of the reflection dynamic class loading stuff that your code might do and feed that information into Graal so that it compiles the right things into the binary so that you don't really have to think about it as much. So it allows you to get around some of those requirements around reflection and dynamic class loading.
So how's that different than ProGuard? Stripping out the code and not using it?
ProGuard doesn't turn it into a native executable.
It just minimizes it.
It just minimizes it. It removes any unused classes and methods. Yeah. I haven't actually used ProGuard, but I have heard of it a little bit. Yeah. Now the other thing is in main frameworks and in Java Enterprise Edition, you have these web application servers, Undertow, Tomcat, Glassfish, whatever. And these things are behemoths, and they're all based on threads, which are expensive and take lots of resources. So what Quercus did is it replaced all the low-level networking that would normally be used for Java EE or Spring with Vertex. And Vertex is a reactive, non-blocking framework. I can talk to you about it for days because I absolutely love Vertex, but we won't go there. But suffice it to say, anything you write in Quercus automatically gets the advantage of it's non-blocking, asynchronous, and very lightweight, because we've swapped out most of the underlying portions of these frameworks with Netty and Vertex. Also, because Quercus really inherits a lot from the Java Enterprise Edition and the Java EE microprofile world, it will soon actually be compliant with the EE microprofile specification. So if you're an enterprise Java developer and you're using things like WebSphere, WebLogic, JBoss, Glassfish in your enterprises, you can actually take all of your compliant code, compile it with Quercus, and move on. No code changes. Unless you're using something specific to that implementation. So if you're using Oracle-specific WebLogic stuff, or IBM-specific OpenLiberty or WebSphere stuff, or if you're using JBoss-specific Java EE stuff, that you might have to change out, except maybe the JBoss. The JBoss stuff is all included because we wrote JBoss. This means that millions of existing enterprise code bases can easily be ported to Quercus with minimal change. Millions. I mean, all of these ginormous ERP systems and enterprise monoliths, we can make them smaller, faster, and containerize them. As I said before, some of the caveats of using Quercus: reflection does not work in native image. Dynamic class loading does not work in native image. And whether you realize it or not, a lot of the libraries and tools that you use under the hood in Java may be using reflection or dynamic class loading. So Spring dependency injection is a huge user of both reflection and dynamic class loading. If you're using a lot of testing tools require that you use reflection or dynamic class loading. So if you're using TestNG or Spot Framework, maybe you might have issues. But it is getting better, and Quercus is adding support for lots and lots of libraries. What they're doing is they're making Weld smarter about those libraries so that it can know what it needs to pull in when it bakes that native image. So let's do some live coding. I mean, seriously, what could go wrong? Live coding always works out in movies, right? We're going to quickly, very quickly, create an actual REST API service using Quercus. And then we're going to create a Docker container, or a container image that we could then load in Kubernetes. And I'll show you how fast it is to start up. So let's hop out of here. And let me mirror my screen real quick. Yeah, it did. It screwed up my resolution. Why do you do that? All right. And just to show you that you don't have to have big money to start using Java, I'm going to do this without any paid software. So everybody read that all right? I'm going to go into my temp directory. We're going to create a new Quercus application. There's a couple of different ways we can do this. One is using the Quarkus Maven plugin. So we can say MVN. You can download Maven from maven.apache.org. It's free software. Lots and lots and lots of Java developers use it to manage their applications. And we type io.quarkus : Quarkus Maven plugin. And we're going to use the latest release, which is 1.0.1 final. And we're going to ask it to create a new Quercus app. It says, okay, what do you want your project group ID to be? We're going to call this us.juggle.demo.
A Perl developer made that.
A Perl developer made what?
The Acme namespace.
Oh.
I've never seen that outside of Perl.
We're going to call our project to do. We're going to accept the default version of 1.0 snapshot. Do we want it to create a REST resource for us? Yeah, okay, that sounds good. US Juggle demo, hello, that works for me. Yeah, that works for me. Boom. So now we can go to do, and we're going to use VS Code. You can download this for free from Microsoft. It's actually a halfway decent IDE.
It is now.
Huh?
It is now.
So all the Java support, all the plugins for Java support for VS Code, bet you never guess where they came from. We made them. And it's getting better. It's not great. I still have a preference for IntelliJ just because it's so far ahead. But you don't need expensive tools to get started in Java is my point. All right, so we have our project. Can everybody read this, or do you want me to zoom in?
A little bigger
How's that?
for the people in the back. There we go.
All right, so it created this hello resource, and interestingly, it created some unit tests for us.
Aw.
Wasn't that nice of them to create unit tests for us?
Generous.
Look at that.
What's that?
How generous.
Indeed. I cannot recommend to you enough that you test your code. Testing your code is how you know you're done. Write your test, implement your code. When the test passes, that's when you're done. Don't do any further than that. So let's look at this hello resource. As we mentioned in the slide, this is using JAX-RS. Later, once we get through this, I can show you a Spring Boot demo that uses the Spring Boot methodologies, but they're really not that much different. It's just slightly different annotations. Everybody here know what an annotation is? You Python people call them decorators. Okay, that's what these little @ symbol things are. They're annotations. It's basically ways to tell the compiler more information about your code, and it will automatically add capabilities to your code. So we have a path. So when we're talking about web resources, we always have a path. You know, you go to google.com/. That's the root. The first slash is the root of the web tree. Well, we're saying that root/hello, that's our hello REST endpoint. We're telling it that we produce plain text, and we're going to return hello to an HTTP GET request. Pretty straightforward and simple, right? So I'm going to fire up a terminal. I'm going to say MVNW. You should use the Maven wrapper that Quercus gives you because Quercus is dependent on the latest version of Maven, and it will always set itself up for the latest version of Maven. You may or may not get the latest version of Maven with your operating system. So /mavenw, Maven wrapper, and we say clean, compile, And then here's a really cool feature of the Quercus Maven plugin. It has a dev mode. Some of you said you do front-end development with JavaScript, right? So if you've ever done front-end development with JavaScript, like using React or Vue or Angular, you can run a dev server, and every time you save a file, you instantly see the changes in your browser. This is true with Quercus now. This is not something that's common to most Java development, but Quercus has this. So for example, we're going to flip my IDE over to that side, and we're going to open a browser on this side, and we're going to go localhost 8080. Hey, it says my cloud native application is ready. And if I go /hello, boom, I see hello. But all I'm going to do is change this to bonjour. And I'm going to hit Control, Save, boom, and reload this page. I did not have to stop and restart the application. I didn't have to recompile. Instantly, my application is up to date. Is this good? Everybody like that? Very nice. Again, JavaScript people have been doing this for a couple years. Good for them. We're catching up. So next step. We need to be able to access some data, right? So let's create a new folder, and we're going to call this Data Entities. Now, if you're at all used to or familiar with Java, Java has this capability called Java Persistence Architecture for doing what's called object relational mapping. So instead of writing database tables and writing SQL queries manually, you map your database to Java objects. And so then you don't have to worry about writing queries all the time. So we're going to create a simple entity called to-do. And we're going to grab the package name is US Java Data Entities. Okay. And we're going to say public class to-do. And our to-do class is going to have a couple of fields on it. We're going to have private long ID. We're going to have private string title of our to-do, private string description of our to-do, private Boolean complete. Is it complete? And we're going to default that to false. We're going to have private offset date time. This is just a Java thing for a time with a date that is specific to a time zone. And we're going to call that due date. Due data. All right, we're going to save that. Now, I'm going to make my life a little bit easier. I'm going to use a little tool that I love, that some of my fellow Java devs are probably already familiar with. I'm going to add a new library. It's called Lombok. And what Lombok does for you is it makes it super fast and simple to create getters, setters, hash code, and equal methods on your objects. Word project Lombok, and then we're going to give it a version. And yes, autocomplete worked for once. And so now, instead of having to write all the getter and setter methods for those fields and having to write an equals and hash code method, I just go at data. And Lombok does it for me. That was easy. Now I also need to tell my application that this is a data entity that I'm going to save in my database. So to do that, I add entity. Uh-oh, entity's not in my path. I need to add the data capability. So Quarkus actually makes this a little bit easy for us. If you're inside of your project and you run Maven W, Quarkus : list extensions. and it will list all of the extension modules that are available for Quercus. Every one of these extensions is compatible with native image for Growl. So if you stick to everything that's in this listed extensions, you're guaranteed to be able to make a native image. Part of this is database drivers and Hibernate, which is a Java persistence architecture implementation. In fact, I think it's now the reference implementation. It's the standard that everybody else goes by. So what we're going to do is we're going to tell Quarkus to add extensions. The extensions equals, and what we're going to do is we're going to add Hibernate ORM, and I'll tell you what panache is here in a few minutes, but you're going to love this. And we need a database driver, so we're just going to use an in-memory database for our example. And we are going to need the ability to return JSON objects from our REST API. And I'm trying to remember, is there anything else we need? Nope, I think that covers it. Yeah. All right, so we're going to press enter. Oh, got too many commas in there, and I don't think it liked spaces either. There we go. Oh, really? Okay, so now if we go back over to our to-do Java, and we entity, there it is. Now it's showing up. So now it's been registered as part of Java persistence. And so this represents a single table in our database for us. And then we're going to use that panache bit that I was talking about. And that's going to give us some really nice capabilities. So by extending panache entity, we get all of the typical data access methods like find all or find by ID or search with these search fields or whatever in my database. I don't have to write those queries. I don't have to write that code. So at this point, I'm basically done except for telling the application the name of my database. And the way we do that in Quercus data sources is Wi-Fi here is not exactly fast. By including that Hibernate and panache, it included this Datasource Manager called agrol. And all we have to do is copy these 3 lines, paste them in here, and say what the URL of our database is. In this case, we're going to do an in-memory to-do database. The username is just going to be SA. We can specify the minimum and maximum size of our database connection pool. And now at this point, if I look at my terminal over here and I hit refresh in my browser, we're going to see some messages. Uh-oh. So it changed source files, no class defined found. So it's showing all of our installed features. But it said no driver has been defined for the default data source. So I guess it didn't quite pick up my application properties changes. I will file a bug on that because the live code reload should automatically take advantage of that. So if we refresh this page, yes, we're up. The next thing we can do is for our development purposes, we can
have Quercus automatically create and destroy our testing tables. So drop and create. So we can add this configuration option to our application properties file. If you're familiar with Spring and Spring Boot, this is how they normally configure their applications, is with an application.properties file. But it's also been part of the Java Enterprise Edition world for quite some time as well. And what this is saying is that when you start up and you connect to the database, it will drop the existing to-do table, and it will create a new one based on what's in our code, so that we can have an environment to work in. Now, we've got our entity. Let's add a new REST controller, and we're going to call this to-do resource Java. And we're going to give it our package name. And we're going to say public class to-do resource. Boom. And all we have to do is say path to-dos. That annotation all by itself is enough for Weld, the dependency injection framework, to detect that this is going to be a REST application and to set it up inside the dependency injection framework. And so now we can add public response get to-dos, and then all we really have to do is say return response.ok to-do, import our entity, list all. Boom. We now have a get endpoint that returns all the to-dos in the database. Who believes me? Oh, error restarting Quercus. Ooh, incompatible types. Oh, this is not a problem with Quarkus. It's a problem with me. I forgot to call build. Hello, what? REST resources, hello, not found. Oh, my package name is wrong. All right, hello's getting in the way. Goodbye. Goodbye to hello. No REST resources discovered. That's import demo data entities cannot be resolved. Okay, see, this is what happens when you live code. All of these demos worked perfectly earlier today.
It's not just me.
Why are my imports not resolving? What's a good thing I didn't go for the more complex example? Oh, you know what? I know what I did wrong. Get produces application underscore JSON. Import static Java X RSWS dot star. No. Oh, WSRS. Helps if you put them in the right order, silly. And then it's media types, isn't it? Or no? Context. Brrr, this is why I hate live coding sometimes. Client container ext core. I think it's under core. Okay, hold on. This is getting on my nerves. Produces media type. IntelliJ would have found that for me. Screw it. Application JSON. Attribute value. What? Oh, I imported the wrong produces. That's why. And now, I'll bet, if I do application JSON, nope, still doesn't like me. Okay, anyway, so now, empty set, blank database, there we go. Got to put the right annotations, folks. So let's say we wanted to add a method to create new to-dos. So we got public, response, add, to-do. And it's going to accept a to-do object. And we're going to say return, response, okay, to-do dot persist new to-do. So persist is just going to add it to the database and give it a unique ID. And then this time we're not going to forget to add the build method at the end. What is this saying? Oh, that's right. To do, new, to do. Persist, new, to do. Okay, but because this is writing to the database, we need to make sure that it's carefully wrapped in a transaction so that two people can't overwrite the same thing at the same time. So we add another annotation to anything that writes to the database to say it's transactional. And boom, that's done. So here in our terminal, we should be able to say curl-x post-h content type application JSON, -d is our data that's going to have our title, and that's the only field we're going to populate because I'm lazy. My to-do, and then we're going to say http://localhost:8080 to-dos. Boom. And it showed me that it added my to-do. And now, if we refresh our list, we see our to-do added to the database successfully. That's pretty quick, would you say? That's a very fast way to write a back-end web application. I'm going to show you something a little bit cooler, a little more complex, but has been prepped a little better than my live coding example now. And for this, I am going to bring up IntelliJ because this is a much more complex process. The thing we're going to start out with first is we're going to use a little open source tool called Apicurio. How many of you have heard of what's called Open API or Swagger for documenting your REST APIs? Many of you have probably seen that you take your REST API, you put decorations or annotations on it, and Swagger gives you this nice little user interface. Well, wouldn't it be better if we start with an API specification and could generate most of our code from it? So that's exactly what we're going to do. We're going to create a new API, and we're going to say juggle to do. And it's going to be a blank API. It's going to be Open API Specification 3.02. We're going to edit our API. And so we can define API paths, we can define data types, and we can define response times. I'm lazy, so I'm going to add a data type that I'm going to call a to-do. And I'm just going to put some example JSON in here. Title, my title, description, my description, complete, false, due date. I'm going to put an ISO timestamp string in here, 12/22 T09:0000 Zulu. And what else do we need? We need title, description, complete, due date. Yep, that's all we need, right?
Hash maps.
What's that?
Put in some hash maps.
And here's what's really cool about Apicurio is it's for lazy people like me, and it says, hey, would you like me to generate the REST definitions for that JSON? And I'm like, yeah, I would. And so when I save just this little piece of example JSON, you'll notice that it populated my get, put, post, delete all for me. It created my data type definition for me. And if we go and look at the source, so for that little bit, I gave it a name of an object and a little example JSON, and it generated, oh, that's too big. It generated the entire Open API specification for CRUD. Everybody know what CRUD is?
Create, read, update, delete.
Create, retrieve, update, delete. But yes, read works as well.
This works with schemas. Schemas for JSON.
So this in Open API, the schema itself is defined in YAML, but you can also define it in JSON. Now, this is thing I've filed a bug report about in Apicurio. This title that it puts on the data type, the root type for to do, when you generate your code from this, it makes an entity called root type for to do in camel case with no spaces. I hate that, so I go in and I fix that. I just changed the title to do. And you'll see that it attaches an operation ID to each of these REST endpoints, these HTTP methods. When we copy out this code, we're going to copy this code. We're going to go into my IDE, into the root of my project, and you'll see I already have this, but I'm going to delete this so that you might have some semblance of believing me. Copy all of this, paste this, and save it. And what I've got here is a Maven multi-module project. The scenario I want to present to you is you have some people that work on back end, you have some people that work on front end, and if you've ever worked in a traditional IT shop, your back end guys are usually lagging a little behind your front end people, and so there's not actually a back end for your front end people to test and develop against immediately. And when they finally get to the point where they're ready to try and marry them up, you have what you call an integration party. Anybody ever heard that term? Integration party? It's usually a nightmare because somebody in the front end interpreted the specification one way,
Someone in the back end interpreted it in a completely different way, and now you have to completely rewrite your code to make them work together. But here's the cool bit. What I've done here, I can't zoom in that. So I'm sorry you can't really read this very easily. Is I've written a Vue.js front end, and it has no implementation of talking to the back end at all. It's just a pretty front end, all right? And I've written this open API spec. Everything else in here, there is no implementation code whatsoever. So the JavaScript client, there is no source code. It's just node modules, right? Empty. The Java client, there's no source, there's not even a source directory in that one. The implementation, source main Java, just a get keep file, right? Now in the front end, like I said, I've already developed this really nice, pretty Vue.js application. Then down here in this server, you'll notice there's not even a source directory there. I am going to run one command. Maven, clean, package. I'm going to skip the tests because I haven't written all the tests. Bad me. And then Quercus, Quarkus, dev. Now this is going to take a few minutes because it's transpiling some JavaScript code, it's generating a bunch of Java code, and from that open API specification that we just had, it's going to create a client SDK that I can include into my Vue.js project. And then from that point, I just say API client create to do, instead of having to work with Axios or make XHR requests or write my own HTTP interfaces or any of that. It just gives it to me for free. And it does it in TypeScript using Axios, so it's fully reactive. And the reason I wired this all up in Maven is because I could do this with one command. I've got Maven actually running npm commands in the back end. It actually installs a local installation of Node.js and npm so that you can run it on any node anywhere. And what I do with this usually is I'll load it up into Jenkins on my Kubernetes cluster. So for example, we would go to my OpenShift cluster. OpenShift is an enterprise version of Kubernetes with some additional functionality. And inside of my OpenShift cluster, I have a Jenkins installation that I can log into. And what you'll see is that I actually have a pipeline that generates that JavaScript client library for me. So Jenkins, it took me a couple tries to get the pipeline file right. So I'm sorry, the 29th time is the charm. And we can actually open this up in Blue Ocean, which is much easier to read. And you'll see exactly the steps that it ran through. It grabbed my OpenAPI specification, it generated the code from it, it transpiled the TypeScript library into ECMAScript, and then it published it to my artifact repository as an NPM package, which I can then include into my front-end application, just using npm install savedev, and then import it as an ECMAScript import. So if you look inside of my front end, you'll see source layouts, main layout. Down here in my code, you'll see a bunch of these notify messages that say data loading is not yet implemented, deleting, not implemented, update, not implemented, so on and so forth. And my Quercus app has finished compiling. And if we go to localhost, here is my pretty UI. And it says, oh, initial data loading is not implemented. And if I try to new to-do, my to-do, add, oh, saving is not implemented yet. Bomber. Well, how difficult can it be to implement, right? Can't be that hard.
So we're going to go up here to the top of our little script block, and we're going to say import API client from to-do JS client. Oh, that named it funny, but all right. And then we're going to say const API client equals new. Oh, actually, I think it's default API. And actually, I think it needs to be wrapped in curlies. There we go. New default API, and we're going to tell it to connect to localhost. Now, if I were actually going to do this normally, I would probably do this in a slightly more dynamic way. But basically, I'm instantiating that client SDK. And I'm telling it that the root for the web service is right there. And now down here, initial data loading is not yet implemented. Well, let's fix that. And we'll say this dot q dot loading show. So we're going to show a loading indicator. Then we're going to say API client dot get to-dos. Hey, that's nice. It just came right up. And we're going to say once we get the to-dos as a result, we need to do something with it. So we're going to say this dot data dot to-dos equals res dot data. But I think, yeah, no, it's just res dot data. Well, that was easy. And then in case of an error, we're going to do this dot q dot notify and error colon JSON stringify my error because that's so secure. But we're also going to tell it to turn off the loading. And up here, we're also going to tell it the same thing. And we're going to tab this in one. So now we've implemented the default loading. So if I go back and I just refresh this page. Oh, right. So the Quercus live coding doesn't understand JavaScript. And so we actually have to manually recompile. Womp womp. So we break that, we rerun. And while we're doing that, let's go ahead and implement these other methods, right? So let's say delete. We can say API client dot, isn't that what I called it? API client. Why aren't you auto-completing for me, VS Code? API client, oh, there we go. Delete to do. We give it, so the index in my to-do array inside the front end may not be the same as my database ID. So in my data to-dos, I grab it by index, and then I use the ID. Then res catch error I forgot to put a semicolon over here. I'll try to be neat. And if it successfully deletes it, then we're going to say this dot data dot to-dos, and we need to remove that item in JavaScript. We do that with array.splice. And we use the index, and we're going to remove one item from the array. Otherwise, we're going to show an error message using our notify. Well, that was easy. So now we've got list and to-do. Let's update a to-do. So we're going to say API client dot update to-do, and we give it the same index ID and the actual to-do, which is just this without the .id. And then we say, when we get a response, we handle the response. We catch any errors. Pretty easy. All right. So you can see how easy this client side is because we've generated the client SDK. Let's take a look at the server side as well. You guys didn't come here to learn JavaScript, right? So OpenAPI has generated, in our generated sources, a server implementation. And it consists of these 6 classes. And part of that is our to-do entity, made up with Panache entity, like we showed you in the demo. And it implemented our to-dos API for us. And with Swagger annotations and everything, it's got our create to-do method, our delete to-do method, all of that stuff. And then it created this interface called to-dos API service. And an interface is basically just saying, I intend to implement this sometime later. Well, now is later. So we're going to go in here into our implementation project, and we're going to say new class, and we're going to call this to-dos API service implementation. Yep, we'll add that to get, and we'll say this implements our to-do API service. Oh, come on, load it. There it is. Excellent. So let me zoom in on this. And the only thing we really need to do here is say at application scope. That tells it that it needs to be detected as part of our dependency injection. So now we've created this class. Oh, we've got this ugly red squiggly line. It says, hey, you must either declare abstract or implement the abstract methods. Okay, so let's implement those methods. Boom, we got those for free from our interface that was generated. So now we need to be able to create a to-do. And the way we do that is we say to-do, because we've got that nice entity, that Panache entity, persist to-do. That's interesting. And then we say return response. Okay, to do, build. Oh, that was really easy. Wait, okay, we need to add transactional because we're writing to the database. So now we've got the ability to create to-dos. That was tough. Let's delete a to-do. Okay, so to delete a to-do is a little more complicated, but not much. To-do dot get, find by ID, to-do ID, and we need to save that to be deleted equals, and then we're going to say to be deleted dot delete. Okay, and then return response dot okay dot build. Because if we're deleting it, there's no body to return, right? We don't need to put anything inside the OK method. Oh, wait, we could probably simplify this a bit even. We could actually go like that and just use a Fluent API to chain those together. And then let's get a single to-do by ID. So that's going to be return response, OK, to-do, find by ID, to-do ID, build. Man, this has got to be the toughest REST API I've ever implemented. Return, response, okay, to-do dot list all, build, okay, get to-do, delete to-do. Okay, we need to update our to-dos. Now this is actually really the toughest one, because we need to go to-do existing equals to-do dot find by ID to-do ID. And then we need to say existing dot set title and to-do get title. And we got to do this for all of our fields. Set due date, get due date, set description, get description, set complete, is complete, and then that's it, right? And then all we need to do is say existing dot persist and return response dot okay, our existing that has been updated and built. There you go. We've implemented every CRUD operation in record time. Now, does it work? That's a good question. Let's see. To-dos. Resource not found. Let me double check my API here. It should be path to-dos. Oh, wait. Ag role dependency is present, but no driver has been defined for the default data source. Right. Okay. So in our POM file, we need our dependencies. I've already added them here, but what I didn't do is I don't think I set up, I didn't create the application.properties. Inside of the implementation. And that's my bad. I actually have it in a different branch. I'm going to do get checkout from master source main resources application.properties. And move source main resources application properties into implementation source main resources. And we should be able to start our application back up, and we have a REST API completely implemented. I've bored you all to tears, haven't I?
So what are our sizes? How does this application look like from the size one you do?
Ah, that's a great question. So the way we can take a look at that is real quickly, instead of doing Quercus dev, we can call package. And this is going to create one Uber jar. Do you guys know what the term Uber jar? You know what a jar is? A Java application archive or a Java archive. So an Uber jar is a Java archive that is executable. You can run it with java-jar jar file, and it will just run because it has its metadata set up so that it can run the application. This is going to create one big Uber jar inside of that implementation subproject, submodule, and that file is going to take a minute. It's building the front end right now, which takes a little while. JavaScript, node install, npm installs, that kind of stuff. But what we can do that's really cool is after that, we can go to the Quarkus guides and learn about compiling it to a native application. So all we need to do is on our Maven command line, if I can find it, come on, registering for reflection, native build args. Where is that stupid command? I would have thought it would have been like right here at the top of the page. Oh, you know what? It's the get started, isn't it? Build native images. That's it. So one thing you will need is you need GraalVM. which is a different thing than the standard Java virtual machine. You just need to have GraalVM installed, and then you need to use the Graal Package Manager, GU, to install the native image capability. Once you have that, and you have an environment variable for your GraalVM home, all you have to do is run this Maven command here. Yeah. Maven w verify -p native. So we see now that it's completed. We're going to go into the implementation folder, ls-l target. Our Uber jar, before we compile to native image, is 1.5 megabytes. Give me an estimate real quick, Austin. How big is just a basic Spring Boot jar file?
Oh goodness,
Hundreds of megs, right?
hold on. I don't know. I was gonna say I don't think hundreds of megs does not sound right.
Let's see. I think I actually have a Spring
But then I do a little
Spring
bit more,
REST.
a smaller.
MVN package. Let's see if this will actually build real quick. And we'll see how big of a Spring Hello World app is. Oh, pardon me.
I've got a demo like microservice with that Spring Boot 14 kilobytes.
14 kilobytes? I don't believe you. That's the executable jar file.
No, it's been a while.
Or is that a WAR?
Nope, not a war.
Oh, let's skip the tests. Dash D skip tests.
Maybe.
If you're talking about Spring MVC, Spring Edge APA, you're probably talking 60 meg already. Just their libraries.
So
Yeah, it's not
18
executable.
meg.
Just a little more things, I guess.
Okay, so all right, Spring Boot. So Quercus 1.5 meg, Spring Boot Hello World 18 meg. So about 11 times larger, 10 times larger, something like that. Now, that doesn't account for our native image. So let's do this same thing. Let's do Maven W verify, and let's do -p native. And we're just going to do this on the implementation. Now, one thing you will notice when you're building a native image, it can take quite a while. -pl implementation. Oh, goodness. I actually have to build everything because of the way it's wired up in my POM file. Sorry. So it's got to rebuild the JavaScript and everything else, unfortunately. I will separate this at some point. What you will notice is when it goes to compile the native image, it's going to take a while because it has to do some really in-depth analysis and some tracing within your application to figure out what all it can bake into the native image and still have it, or what all it can keep out of the native image and still have it work. But that native image is probably going to be less than a meg.
This is an executable it's been created.
Yes, it's an ELF executable that can run on Linux, but you can have it compile Windows executables or Mac OS executables as well. You just have to get the appropriate GraalVM implementation for your platform.
A generic Linux, so it could be any Linux?
Yes. And in fact, the only thing it needs is glibc.
Wow.
So any Linux, it will run on any Linux. And in fact, if you're running it in a container, all that container needs is glibc. You can run the barest minimum container possible.
So he could run that on Raspberry Pi.
Oh, yes,
Yeah.
very easily.
Yeah.
Oh, I forgot to skip tests. Dang. Frustrating. I should have written myself a script. to read from.
Specify, sorry, the CPU that you're compiling to? How does it, where are you getting that information from when you're?
That's a great question. I've never tried to compile for ARM. I believe that there is growl for ARM. I think I've read about it, but you might actually have to compile on ARM. I don't know if there's a cross-compiler toolchain for that, which means it's probably going to be really slow to compile. There might be a cross-compiler toolchain. I don't know.
It probably is, because there's for everything else. I mean, it's just complicated. And
Yeah, cross-compilers are always complicated. That's why I don't mess with them.
And there aren't that many people out
It's
there
one of the
doing it.
reasons I love Java is write once, run everywhere. The bytecode works on every platform as long as there's a JVM. All right, so now it's getting into the point where it's building the native image, and what it's doing in the actual background is it's actually starting up the application inside of a profiler. If you don't know what a profiler is, basically it's a way of running your code in an instrumented environment where everything that happens is monitored. And it's watching every class that gets loaded, every method that gets called, every reflection call that happens. And it's compiling what they call a hint file for growl. And then it's using that hint file to just load what's required to run your application into that native executable with Substrate VM. You can think of Substrate VM as the Java virtual machine minus all of the Java default libraries. And it only puts in exactly what your application needs to run. And in a second, I will show you. Yes, it's done. So implementation, target, ls-lh. All right, so here is our runnable jar file, 1.5 megs. This is our runnable native image, and I can show you file. This is an ELF Linux 64-bit executable file. Now you'll notice it's 41 megabytes. But this is a jar file that requires a Java virtual machine, which means that you also need user share JVM. No, user lib JVM. Yeah, open. Yeah, Java 1.8.0 OpenJDK 64. Which is 153 megs. So, yes, this is small at 1.5 megs, but it also requires a Java virtual machine of 153 megs. This runs by itself with no Java virtual machine. So if we actually do java-jar and run the Uber jar, watch the startup time. 459 millis. Not too bad. Now, let's try it with the native executable. Oh, got to put // 22 millis. And to prove that it's actually working, ooh, cross-site request forgery error. Well, that's interesting. Oh, you know what? I forgot. In my application properties, I needed to use Quercus cores and recompile it with Quercus cores. I apologize. So I didn't have cores headers turned on. Cross-origin request something. I forget. So 22 milliseconds to start up on a 41 megabyte file that is literally 1/5 the size of what would happen if you deployed it using the JVM.
Because you didn't cache it, so probably much faster because of the caching, memory caching, and pulling it into memory again. It's already there.
Oh, if I were to restart it, you mean?
Yeah.
Now, yeah,
It wouldn't
point
make a difference.
19 millis. Now, why is this important that the startup time is such a big factor? Well, The real problem is if you're working on cloud native, if you're deploying to AWS or EC2 or Kubernetes or Google Compute or whatever, what you really want to do is you want to run the minimum possible at any given time, and you want to be able to scale up with demand. If your JVM takes 2 or 3 seconds to start up your application and get it running, that's 2 or 3 seconds that you can't respond as quickly. If your application spins up in 22 milliseconds, you can scale out faster and handle demand better. That's the whole point of this. Make sense?
And you can make your applications really small. As part of the application, have it be started CGI, still using an HTTP interface. So you can start up your applications on HTTP request.
Yes, and in fact, Quercus actually has a set of modules and libraries for running in serverless mode. So you can run this in AWS Lambda, or you can run it using Knative on Kubernetes. So you can literally deploy this application, have it scale to 0, and using Knative or Lambda, it will on demand launch this application, answer the request, and shut it back down again. So you can do serverless with Java. Now, let's dispel a couple of myths. A lot of people harsh on Java because it's old and they have this perceived notion of what Java used to be, not what it is anymore. So you'll hear a lot of JavaScript people talk bad about, oh yeah, but JavaScript's fully, reactive and non-blocking, and like, yes, so is Java these days. Java has had futures and completion stages and things like that for a long time now. And then you'll hear people say, oh, but the V8 JavaScript engine starts up faster. Well, no. No, the V8 JavaScript engine takes upwards of 800 or 900 milliseconds just to start up before it ever starts interpreting any code. In fact, if you go to this wonderful little website, if you've never been here, this is kind of fun, Tech Empower. Tech Empower does these framework benchmarks a couple times a year with all the top REST frameworks. And the most recent round was round 18, which was done back in August of this year. And I want you to notice something here is if we go down the languages that are the fastest on here, and the first time we see JavaScript is, oh, it's going to be a while. PHP. Oh, wait. Oh, there you go. There's the first JS. So JavaScript. Oh, wait. This is ES4X. That's the first entry for JavaScript, but I know the guy that wrote this. You know what this means? This is ECMAScript for Vertex. This is JavaScript running on the JVM. That's the fastest JavaScript implementation out there, because this runs inside of Gra. This thing is more than 20 times faster than the next closest Node.js V8 engine competitor. So the fastest JavaScript engine in the world is actually Java. I always find that really amusing. But you know what's really sad, though, is next in line is PHP, and that just makes me feel dirty. Actually, I harsh a lot on PHP, but PHP is a perfectly valid choice for a lot of applications. If you don't need massive levels of scalar performance, PHP works great, and it's super simple to write. Super simple to test, super simple to get going. But yes, so if we actually scroll down a little bit further, I think we can find the next, there we go. There's the next fastest JavaScript. This is Polka Dot Framework with Postgres. I don't recommend trying to use Polka Dot. It's actually really hard to code in. The first easy one is probably going to be around Express. Express is somewhere down around 200 in the list. So, yeah. I do encourage you to check out ES4X if you're interested in writing web applications. reactive web applications. Super fast, super easy. You use NPM just like you would any other Node.js app, but it all runs on top of GraalVM, which is pretty cool. And the other thing I want to show you while we're here is if you look, we said that the core I/O for Quarkus is Vertex. Vertex is the 5th fastest framework in this benchmark. The only thing that is preventing Vertex from being top of this list is the one thing that Java really sucks at, and that's converting data to JSON. It's the only thing holding Vertex back. For a long time, Vertex was top of 4 out of 6 of these benchmarks, and the only one it never could get into the top 5 for was JSON serialization. For some reason, Java just sucks at turning data objects into JSON. It's something that's done really well in C. That should change with GraalVM, because in GraalVM, you can actually call native C methods without having to use Java, JNA, JNI, the Java native interface, Java native architecture. So you can actually just call straight to C functions without any kind of interface in between. So that'll probably get broken here soon too. All right, that's my demo. I hopefully showed you how easy it is to convert from traditional REST API development to Quarkus REST API development, because there really isn't any difference in the code whatsoever. We've implemented all of this. The under the hood of Quercus is Java Enterprise Edition, or Jakarta EE micro profile. So it's implemented using small RAI, it's implemented using Weld, it's implemented using Hibernate. These are all things that are standard in the Java world. It's what everybody uses. Even the Spring Boot world uses JPA with Hibernate. And really, we've taken those same APIs and made it so that you can compile them to a native image and run on top of a reactive I/O, or reactive networking, reactive I/O interface. And that makes everything super fast. If you go to the Quercus I/O website, they will show you some benchmarks, and they will show you the methodologies for those benchmarks. But I actually love this graphic on the main page. Here. Okay. So if you look at this, here's a Graal native VM REST API, 12 megabytes. We saw something very comparable, 14 megabytes. Quercus with the JVM using OpenJDK is 73 megabytes. I showed you 153 megabytes. That's because it was the Java development kit, not the Java runtime. My bad. And then a traditional cloud native stack. This is like a full Spring Boot, Spring Security, Spring Data JPA, or Drop Wizard, or Java EE type application. Okay. Now REST with CRUD, similar, but here's where it gets really awesome, is those first boot and response times. So Quercus gets started in 0.016 seconds. We saw something very similar in our demo. And Quercus native with GraalVM, with REST plus CRUD is 42 millis. But what's really interesting is this is not just boot. This is boot and first able to respond to a web request. In a traditional JVM, you can get your application up and running in probably, 400, 500, 600 milliseconds. But is it actually able to answer requests? Well, generally it takes 2 seconds for simple stuff. But you can see their demo, and you can look at what their actual benchmarking is. They're saying that from a traditional cloud native stack, it's 4.5 seconds to 9.5 seconds to be able to answer your first response. The other thing is, they don't have those numbers up anymore. They used to have a comparison of the binary size between a Quercus app and a Go app that does the same thing, a REST API with CRUD operations, and they're almost the same size. And the startup times are almost exactly the same as well. That's really cool.
8:30.
And with that, I'll open it up for questions.
What time is it?
It's 8:30. Unless I accidentally do my touch bar. Are we at 8 o'clock in that too?
Thank you for putting up with my hour-and-a-half marathon. No questions at all?
If we wanted to learn even more and implement our own, what is the next resource that we could go investigate other than Quercus.io? Do you have?
I'm glad you asked. I actually shared that with the meetup group. If you go to learn.openshift.com and building applications on OpenShift and developing with Quercus. These are, how many of you here are familiar with Katacoda? There's a website, Katacoda. They give you this library of scenarios you can run through for IT and development and all kinds of other stuff. These are Katacoda scenarios that you can walk through. So if you wanted to get started, if you wanted to review this yourself, you can go here and it will give you a web-based IDE and environment to run this. So you can just start this scenario and it walks you through creating a new Quercus app and building a greeting service. There's a web-based IDE. It even gives you access to a Kubernetes cluster to deploy it on and try it out on. You can actually hit it with your own web browser, try things out. There are 5 different Quercus scenarios in the Katacodas. And if you get to the point where you've gotten bored with the scenarios, I believe if you go 2 levels up, there is an OpenShift playground. This is an OpenShift Kubernetes cluster running Kubernetes 1.15.6, I think, or OpenShift 4.2 is what we call it. I think it stays up for 2 days. You get a Kubernetes cluster you can play with for 2 days. At the end of which, you can go back and you can create a new playground. Realize it's got limited memory, limited CPU, because we're paying for this out of our own pockets. This is all running on AWS. It ain't free. But you can use it as much as you want to learn. And in that OpenShift playground, you can deploy what's called code-ready workspaces, which is a web-based development environment. And you can work on any of the Red Hat stacks, any of the open source development tooling that we have available, which includes Node.js, it includes Spring Boot using Snowdrop, it includes Vertex, it includes Quarkus, it includes Java Enterprise Edition, or Jakarta EE as it's now known. All of that you can go play with. So learn.openshift.com is the website, and you can have fun and experiment till your heart's content. Any other questions?
Suppose I wanted to set this up, Quarkus, on, let's say, a GoDaddy or a Amazon server. Is that anything stopping you from doing that?
No, especially if you're compiling the native image, it'll run anywhere. And then if you don't worry about native image, it'll run anywhere Java will run.
Is it stable? I mean, is it so new that it's not stable? It's still a work in progress?
No, it's perfectly stable. So Quarkus isn't technically anything new. It's just a new arrangement of things that have been around for years.
Is the industry accepting it?
Is the industry accepting it? That depends on what you mean by is the industry accepting it. It's already being adopted by some very large players. Yes. Yes. It is getting lots of attention in the tech media lately. And our developer advocates are flying all over the world to tell customers about it on a regular basis because they're being asked about it.
Check out YouTube, there's quite a bit on YouTube.
Yeah.
Watching some of it.
Just go to the Red Hat Developers channel on YouTube. There's plenty of videos about Quarkus and Service Mesh and Kubernetes and all kinds of other great technologies that are out there. Mm-hmm. Any other questions? Yes? No? All right. Well, thank you all for coming. I appreciate your time and attention. and let me know if there's anything else I can help you with.